So we're on level 3 of Google's cross-site scripting game. Again, the game that supposedly Google created initially and used as part of their interview process for hackers and security engineers. And level 3 has the title, That Sinking Feeling. It says, mission description. As you've seen in the previous level, some common JavaScript functions are execution sinks, which means that they will cause the browser to execute any scripts that appear in their input. Okay, so an execution sink isn't always something that you would assume involves JavaScript. There are also execution sinks that do things like create DOM nodes, because if you create DOM nodes, you can create other nodes that then execute JavaScript. So an execution sink is just something that'll take an arbitrary input and do something else, eventually leaving to execution. The execution doesn't have to occur right there. So it says sometimes this fact is hidden by higher level APIs which use one of these functions under the hood. The application on this level is using a hidden sink. Okay, so what that means to me is that on this level there's not going to be anywhere for us to maybe get a script tag. We probably won't be able to get an image tag. It sounds like there's probably going to be some part of this page that reads data from what's called a source, and a source is typically a part of the browser API or the JavaScript API that stores data. And so if a built-in function relies on a source for data and we can modify that source, the built-in function will then become the JavaScript sink for the cross-site scripting attack. So mission objective. It says, as before, inject a script to pop up a JavaScript alert in the app. Okay, that's same as we've been doing. Since you can't enter your payload anywhere in the application, yep, there it is, you will have to manually edit the address in the URL bar below. Okay, so it's giving, I feel like this is basically giving away the answer. It says you will have to manually edit the address in the URL bar below. So this is called Cloud Diddly. That's an odd name for an application. And it says take a tour of our cloud data center. And it has image 3, image 2, image 1. So this is a cloud data center from, looks like, I don't know, 1965. And these computers probably took up a whole room and had, like, I don't know, not even a megabyte of RAM. Okay, cool. So if we look at the URL up here, it looks like we're on the same XSS game, level 3, frame number 1. I assume if we put a 2 in here, we'll go to image 2. If we put a 1 in here, we will go to image 1. Okay, so something's going on here. There's some JavaScript that is executing. And let me take a step back actually. So right here, when we load up this website, this is the data that the server is most likely going to be referencing when it determines what page to load. Okay, so what that means is this is all probably part of the same page. The hash is used by the client to pass around data, typically not used by the server in any capacity. So anything you see after the hash, that's like client-side data. That's for your browser. So that tells me that this is all the same web page, and there's some type of script that is changing the image. So if there's some type of script that's changing the image based on the number after frame, that means that the value right here is probably the source, and the script is probably contains the sink. So let's try something here. Let's try seeing where can we start? Well, you know, there's a couple ways we can go about this. One way we can go about this is we could actually dig deep, and we can go over to the sources tab, and we can check out right here. Let's see, like this is the level 3 HTML, and we can actually find the script that's executing probably in the frame is my guess. Let's see, level 3 frame. Using the browser developer tools, we go to sources, we dig deep into this internal frame right here. Most of the time you don't need to go into a frame, and we find this code right here under level 3, and it looks like there's a choose tab function that takes a number. So this is a string right here, right? And this string has a tag at the end. It has a BR tag, which is a line break tag. So that tells me that somehow this HTML string generated here is actually going to be injected, it looks like maybe using jQuery, yep, jQuery right here, directly into the page, potentially leading to script execution. So let's try something here. Let's try doing a script alert, a script, and see what that does. So here we're getting image, not a number. If we jump back over here, it says div ID tab content. Okay, so it looks like image, not number. We've seen that image before. If we jump back to sources and we go to tab content right here, we can see that image has appended to it the string value of parseInt. So this is actually really, really good news, because all we have to do is figure out how to escape out right here, and then we have execution. We already know this is getting dropped directly into the DOM. So what does parseInt expect? Well, obviously it expects an integer. So we put an integer in, that's going to fire. The next thing we're going to do is we're going to end up inside of a string. So we're going to have a 1 that's appended to image, so it's going to be image space 1 with a BR at the end. So we need to escape that. So we can escape that like this, and then we can try our script tag. So here, let's look at what happened. So we have this image, the integer 1 ended up there, but it looks like we were unable to actually escape out. However, it looks like this was actually appended inside of the image tag, and what that tells me is we could use that onError function again, the one that we used, I believe, in the last level. So let's jump back over to sources, and this time, instead of trying to jump all the way out and create our own script tag, because then we'd have to escape even further, why don't we just try an onError, and let's set that onError equal to alert, and see what happens. Bingo. So this is a very good example of how sinks and sources are important in JavaScript, especially when you're dealing with cross-site scripting. When we're looking at the DOM, there's so many places in the browser DOM model, so many places in JavaScript where you can store data. So the inputs don't always have to come directly from a user input. Oftentimes the inputs can come from things like, in this case, the URL. As long as the input, aka the source, has an associated sink, then all we have to do is connect the two correctly in order to get script execution. In this case, we satisfied the requirements of parseInt, we escaped out of the string, and then we added an onError alert attribute, which fired the alert, which allowed us to get the script execution, and will bring us to level 4.